Okay, now we have to look at them graphically, okay? Graphically, they want you to find the inverse of g of 3. Look over on this graph, okay? When you find the inverse of a function, what was the first step that I said that we needed to do?
The horizontal and vertical line test.
Yep, but if we flip back right over here, what did I say that we needed to do? Switch the x and the y's, okay? If we want to find the inverse of g of 3 when x is 3, that would be, what does g of 3 equal? Okay. So then this,
Yeah.
4 over
I've got my
3.
phone in the French room.
okay, go get it. Okay. So you have to figure out then if you're going to switch them. Do you understand that or not? So this is then on this original graph where y is 3.
So whenever it says G parentheses with the Y.
That's on the original one where it is over here. Okay?
I don't get why you
Okay. When y equals 3, what does x equal?
Y is 3, X is
2. Okay? So that means g, the inverse of g of 3 is 2. Okay? Does that make sense? So that means the inverse of 3 equals 2. I just switched these two around. See? That became the x, this became the y.
Oh,
All right, take a look at this one. What is the inverse of 2? Now, this is on the original graph. When y equaled 2, what did x equal? Okay, so now, on this one, what does this equal?
So no matter what, whatever the X is always gonna be
1, 2, so it's going to go through right there. Okay, do you see that?
Yeah, because x is 0, and it's y.
And I switched the x and the y's. All right,
Because y is 2, right?
yep.
And then we switched them so x is 2 and y is 0.
Right, now look at this one. When y is 0, what is x?
When y is 0, x is still 2, isn't it? Or, I mean, yeah,
G of 0.
g of 0 is 0.
X is what?
Negative 1.5.
Okay, so when x equals 0, y equals negative 1.5. That means the inverse of 0 is negative 1.5. Okay? Right there. What about this one? When y is negative 1, x equals negative 2. So that means this equals negative 2. Now, if you took a ruler and you drew a line straight through the middle of your paper, okay, and the line here is y equals x. It's at an exact 45 degrees. And then we took the paper and we folded it right on that line. This point matches up to this point. This point matches up to this one. This one matches up to this one. And this one matches up to that one right there. Okay? That's how you find the inverse of each other. And then you can draw what it would look like.
Then equal negative 2 on the left.
Yeah, this is a negative 2, yes. So to sketch the inverse of a graph, fold it along the y equals x axis, and then that is how it will show up on the other side. Okay? If you represent a function as ordered pairs, the roles of x and y are switched when you write the inverse function as ordered pairs. So for example, here's a function And these ordered pairs work for this function. That means if I sketch this function, these numbers I could find on the function. X to the 1/3 is the inverse of that, or the cube root. So the ordered pairs that go with this, what would be the first one? What do? You just what? Switch them. So what is the first one?
Negative 27 to negative 3.
There you go. Okay?
Negative 8 to negative 2. Negative 1 to negative 1.
Okay, that one just is the same.
0 to 0. 1 to 1.
Now, question. How come these two, all right, well, we'll finish and then we'll keep
3 to
going.
3.
Wait, isn't it 8 to 2?
Yes,
Yeah.
thank you.
No, Mason, I thought it was 8 to 2.
I wrote it wrong. How come these three in the middle,
Ironic, it is almost 8 to 2.
how come those three in the middle don't change?
Well, because they're the same both ways, or not?
And they lie right on the y equals x line. This is 0, 0. This is 1, 1. That's negative 1, 1. Okay? So if they lie on the line, then they're not going to change any. Okay?
How do you-
Yep, go ahead.
The inverse of the point 1, 1?
The inverse of the point 1, 1 right there. Well, because it lies right on the line, it is 1, 1 again. Because the x and y just switch. So they're just the same. Ones that lie right on the line, they just remain the same. They don't get moved. Okay? Okay, the domain of the function y becomes the range of the inverse function, which makes sense because if they were the x's here, then they become the y's here. And if they were the y's on a regular function, then they become the x's on the inverse function. Does that make sense?
Yep.
All right. Okay, graphical symmetry. Try to graph y equals x cubed on here. Then we're going to graph this one. Plot these points right there on the graph, okay? I want you to, yep, just plot them on the graph right there. Plot them. These points right here. Negative 3. Do this one first, and then graph that one right there. Oh, negative 3 is not in here? 1, 2, 3. Oh, you might have to go by twos then. Maybe go do it by twos. But go ahead and graph those points.